So we've looked at our world volume. So let's say we wanted to add a daughter volume to this world volume. So below we've got the template for a reminder of the different functions for a G4 box. So let's say we want to place a 50 centimeter box inside of our world volume. So let's just add a comment here. So let's say water box 50 centimeters cubed size. So let's just start with some variables for our box. So let's call this and when we're making our variables, we always use G4 double to give dimensions, because this might be used to just using good old double, whereas G4 double is pretty much as a double, but it has an associated dimension to it. So we can actually specify how big we want our geometry, our variable to be. And we could use meters, centimeters, and millimeters or anything, and Geant4 would keep track of our units, so we wouldn't have to use the same units for everything. We could just mix and match. Say we wanted to make 1 micron box, and we also wanted to place it in like a 1 kilometer box, then we don't have to just use the same units, so we can just use whatever is the most convenient unit for us. So let's say we want to make this box 50 centimeters, so let's go box X and let's go 50 centimeters, and let's go box Y, and just to show the interchangeable of dimensions, let's put that as meters for the Y, and then finally let's have just box Z, and let's go 500 millimeters just to be fun. So once we've defined our sizes that we want to use, let's just make the box itself. So go G4 box, and it's pointer, so put an asterisk there, and let's just call this solid box. Let's go box for shortness. Let's go water box. All right, so new G4 box, and give it any name we want. Let's just go water box, and then we give it the half sizes we want to give it. So remember, this is distance. This argument here that we're entering is how far from the origin we want to go. So we then double it to give the total size. So let's go box X divided by 2, and let's go box Y divided by 2, and box Z divided by 2, and semicolon. Then, just because we're just new and starting editing our construction, always a good idea to compile frequently, just in case you make an error at the start. You don't want to have to have a lot of errors after writing lots of code and then try to work out where the error is. So always good to compile frequently. And when you do this, you might get lots of warnings for unused variables. And in this case, if you look here, our first one's G4 water, unused, and it's up here. It's just because currently it's not being used for anything else. It's just defined but never used. And also for the water box, again, it's just defined, but it isn't used after that point. So don't be too worried if you see warnings appear. So once we've made our G4 box, it compiled okay, so we didn't spell anything wrong. So then we can make a logical volume from it. So syntax for that, logical volume, asterisk for symbolize pointer. Then let's give it, let's call it log box, and then go new G4 logical volume, and so the first input will be the solid that we want to assign a material. So in this case, water box, put that there. Then we want to give it a material name as the next argument. So let's make our box water. So we'll just go water there, and then give it a name. So let's just go log box, and let's go log water box. Doesn't really matter, so we won't ever use it, but why not? So then just 0, 0 at the end. So just to get a bit of gratification, let's compile and make sure we didn't spell anything wrong or miss any colons or commas. So we've made our G4 logical box. Since we've compiled this, just to illustrate a point, I'll just run the simulation at the moment. And again, currently we see no other volumes in our world. So, just to show that just because we've got this box and logical volume, we still haven't got any volume placed in our world. Actually, if we wanted to double check that, we could go to our build directory, and let's just edit our, does this have this.mat? Well, I'll do it in a later stage for now. But so we've defined our logical volume. So the next stage is to make a physical volume. So we could just go physical volume. So G4V physical volume, and then give it a name. Let's go phys box and go new, and we use this G4 PV placement function. Remember, the first one is just rotation matrix. We're not using any rotation matrices. So we can just give a 0, and then our next argument is its location in the world. So let's just give that 0, 0. Just put them right next to each other. And then if we just check our G4 placement order of arguments, so if you actually were to look up, like if you just Google G4 PV placement and looked at this function, then you could get source code of this function. And what you'd find out is there's multiple functions, like there's multiple combinations that this function accepts. So this is what we call as overloading a function, where we've got a function with the same name, but it's got multiple different options. So if you, for instance, if you wanted in this case, there's a sphere, so the G4 orb, and you can specify whether you want a full sphere or if you just want a slight angled sphere. Then you can just enter one value if you just want a full solid sphere, but there's another function which takes another combination of angles. So in Geant4, if you have errors in your code, you might actually be told error with this function does not accept the combination you entered. So if let's just show something quickly. So let's say I didn't enter water, but I accidentally entered a water box. So let's compile that, and it's loaded there. So if we just compile that now, so we get this error, no matching function for core G4 logical volume, G4 logical volume, G4 box, G4 box. So this is what we entered into the function in our code. So we gave it a G4 box, and the constant here, this is just the name we gave it, and then those 3 zeros at the end. And then what the compiler will tell us is what it expected. So here this isn't actually doing it nicely. Where's expected? Oh, sorry. So here's how expected down here in readable form. So the error occurred here, and it was saying you entered the wrong things. This is what you entered here. And then if you go down, it should actually tell you what the Geant4 logical volume expects. So in this case, Geant4 logical, it expects to be given a G4V virtual solid, then expects to be given Geant4 material, then a name, and these other arguments which we just entered 0. So that's just one thing to be aware of when you're giving it, when you get errors, and it'll also tell you what it expects. So it'll tell you what type of variables you entered. So in this case, we entered a G4 box or a solid instead of entering a material. So if we just change that back to our water variable there, then once we compile that, it should be happy. Good. So with our G4 physical placement, so it's always handy to, if you're new to any function, it's always good to look at the reference. So with the first one, we expect a rotation matrix, then its position, and then for this particular version of the G4 PV placement function, it expects the current volume. So it's the logical volume that we want to place. So in this case, it's the logical box. So if we go log box there, then if we check the definition, our function definition, then after the current volume expects a name. So this is just the identifier for this physical volume. So remember, when we shoot a particle, it returns a physical volume name of the volume that the particle is currently in. So this will be the name that the simulation returns when the particle is in it. So let's just call it phys box again, special. So then checking our expected argument for the function. So after the physical name, it then expects the mother logical volume. And in this case, this is just the logical world. So we'll give it the name here. So logical world. And of course, you can copy and paste. So we'll just put that there and check what the next one is. So this is p-many for future can be set to false. So that's just for future software feature. So we just set that as false. And then copy number. So put this as 0 since this is the first copy number. So if we want to place multiple, we could give it another, put it as a 1. So after our copy number, we then do we want to check for overlaps, and that can be true or false or just a 0 1. So in my case, I want to check for overlaps. And now that's saved. Let's try and compile it and see if we made any errors. And also another thing with G4 placements with physical volumes, often you'll get these warnings about unused variables. If you want to get rid of that, you can just go new, I think it's something like that. And if you compile that, that should work and get rid of the errors. Yeah, so I personally like having the names there just because I find it easy to keep track of, but if you want to get rid of those warnings, that's all you have to do. So that will compile either way, but this one will just give a warning about it being unused even though it's being placed. So let's just run the simulation in interactive mode again. So you can now see we've got our extra solid placed in this world volume, and if I just maximize that, and I'll just scroll up a bit, and I'll just change this a bit smaller. Ooh. Okay, let's not test the off-campus connection too much. So if you scroll down this log box a bit, you will see check for overlaps. It's okay. So in this case, you see Fizzbox. So remember, that's the name we gave it here. So Fizzbox, that's the name there, and it says okay. So it means it was placed okay, like, you know, it didn't overlap with anything. Though if we, let's say we moved it slightly, so let's say we wanted to shift the origin position to 60 centimeters. Oops, so 60. So remember, our world volume is 1 meter cube, and our box inside this world volume is 50 centimeters. So we've shifted the placement in the world volume to 60 in the X. So, you know, and it's going, so let's just compile that again. And we visualize again. So remember, this is Y and Z. So if we just rotate it a bit here, you can see that we're no longer we're no longer fully within the world volume. So if we scroll up to the top of our simulation, and if we go down, we can see that when we're placing the fizz box, so this volume here, then it detects an overlap. So it will say overlap is detected, volume fizz box, so this one here, with its mother volume logical world G4 box, and it's giving the location that it detected this overlap at. So if you see these weird numbers and thinking, why are these numbers so weird? The way that Geant4 detects for overlaps is it generates random points on the surface of volumes, and so that's why the random points being quoted, because it's generating random points on the surface and just seeing if they match with any other volumes. So we see an overlap there. So I'll also show what this would look like if we were running in batch mode. So let's just go to our run electron.mac, and remember in the video about geometry, I mentioned the Geant4 particle is helpful for debugging. So I'll just change the particle type to a Geant4 in a macro, and since our world is 50, our half world is 50, since it's a meter cubed in total, let's change it from positive 50 as its starting position. So this is the starting position of the particle. So it's starting at x equals 50 and then 0, 0 for the y and z. And let's change its direction here to be -1. So this means the particle is moving in the positive x direction. It starts in the positive x direction and then it moves to the minus x direction. So we'll put tracking verbose 1, so then we see where the particle's going. So if we just run the simulation in batch mode now, what am I doing? Running run electron.mac. Remember, this is actually Geant4, so just a fake particle. So if I just run that quickly, then you'll see the particle actually was generated on the fizzbox. So let's actually just change the direction to -50 and let's have it in the positive direction instead, just to make it start in the world volume instead of world volume. So here you can see the particles being generated at -500 and 0 millimeters, and you see it's being generated in the physical world, and then you see its next step, and in this case, because it's Geant4, this will only occur for new volumes, and you see that it's occurring in the out of world, so it's past the volume. Oh, wait a minute, we're still going in the Z direction. What did I do there? All right, sorry. So I just realized why I was going in the Z direction still. So when we had this output, I was expecting it to start in the physical world and then enter our secondary daughter box, so this volume called fizzbox, but instead I was going in the Z direction. And I just realized that in the macro, because we were set up in the Z direction, then we can't use this beam1D. And you don't need to worry too much about this, but that's just because the general particle source, it defines directions often in the Z direction. So if you define an angle or any sort of weird beam plane, then it will take it in Z, and that's why. So you don't need to worry about too much. So if I run again, I've already got the output here, then we can see a bit more of a expected output of it being generated in the physical world and then going to the physical box, and then eventually it goes to the out of world. So if we just scroll up here, keep going. Ooh. Okay, I'll just pipe. Oh. Okay, I just ran it and cancelled quickly. So here again, we see this overlap detected, and so it occurs for the volume G4, for fizzbox, which is the top G4 box, and it's occurring with its mother volume. So this was just to show that regardless if you run it in batch mode, such as run electron, or whether you run in interactive mode, you'll still be able to see these errors. So again, so what we just did with our macro is we started a beam over here at -50x centimeters, and we shot it in the positive x direction. So if we were to look at our last outputs, it started -500x, then the next remember Geant4 forces a step wherever there's a new volume. So at 350 in the X, so over here, that's where our box starts, and then it keeps on going in this fizz box until it reaches the end of the fizz box, which is 850 in this case, because of the size of the box of this fizz box. And you'll note that this 850, this is larger than the world itself, which should only go up to 500. So you can do checking with either visualization in interactive mode or with batch mode. So let's just fix up our geometry location. So let's just change that back to the origin for now. So if we recompile it, so remember, if you have overlaps in your geometry, this won't be detected when you compile it, since there's nothing wrong with putting 60 here, like in terms of the software point of view. It's only when you actually run it and it's got an error in terms of Geant4 itself, so that's why it compiles just fine, but you have to run it to actually determine whether there's overlap. So if we run it interactive mode again, and see we're now fully in our world volume. So if we scroll down, it places the G4 box, and it's okay now since it's fully inside the world volume. And similarly, if we did this for the interactive mode, so if we ran it with the macro, where we're again see okay there. So if we scroll down, if we scroll down, we can see it's the this particle is generated at minus 500 millimeters in the X and goes to minus 250. So this is the start of the box, and then it has another step at 250 where the box ends and the world starts. And in this case, the particle ends being tracked at 500. So this is the end of the world. And whereas before, because the daughter volume, so fizz box, it extended outside of the world volume, and because the particle entered this fizz box, it continued being tracked in this fizz box, which extended outside of the world. So in the next video, I'll just show how to add a bit of color to your volume. So we'll play around with visualization attributes.